Hi and good day to our lecturer Dr. Ashikin and my fellow friends. Today we'll be presenting on the topic of quantum chemistry about Albert Einstein. Who is Albert Einstein? He who was widely regarded as the most influential physicist of the 20th century. His very name remains globally synonymous with a supreme human intelligence and creativity. Second, the radical shift in reality viewed the laws of nature not as unchangeable rules but as an interconnected puzzle to be unlocked through independent, non-conformist thinking. The first of all is ultraviolet catastrophe. So the first one is the classical framework failed completely when trying to explain how hot objects emit thermal energy, that is black body radiation, solving photoelectric mystery. This particular theory perfectly explains why shining light on metal ejects electron based on the light's frequency, that is color, and not its intensity, which is brightness. Achievement. While famous for relativity, it was the specific discovery of the law of the photoelectric effect that won Albert Einstein the 1921 Nobel Prize in Physics. Albert Einstein's scientific background. In the year 2000, Einstein's photon theory formed the foundation of modern quantum mechanics, enabling technologies such as solar cells, digital camera, optical sensors, and photodetectors.
Look at the impacts of these discoveries on science and society. First, Albert Einstein introduced the photoelectric effect, proving that light is made out of discrete particles called photons rather than just behaving as a wave. He explained how light of sufficient frequency knocks electrons off a metal surface. This breakthrough solved major physics mysteries and laid the groundwork for quantum physics. Practically, this law taught us how to turn light into electricity. Ultimately, these discoveries paved the way for our modern electronics and communication technologies. Next, Einstein's theory of relativity heavily influenced both science and technology. In the year 1905, he proved that atoms exist, and his famous equation E equals to mc squared showed that mass contains a massive amount of energy, which later led to the first atomic bomb. On a brighter note, his relativity theories directly influenced the development of television, allowing us to receive sharp images on screen. This work, alongside his photoelectric effect discovery, earned him Nobel Prize for Physics in 1921. Finally, these discoveries enhanced public appreciation for science worldwide. By exposing the limitation for classic physics, Einstein changed how we understand nature and inspired a global wave of interest and curiosity in modern science.
Quantum-related discovery, which is the photoelectric effect. So, firstly, Einstein proposed that light behaves not only as a wave but also as a particle called photon. As shown in the equation, E equals to hf, the energy of a photon depends on its frequency. So, this discovery changed our understanding of light and became a foundation of modern quantum physics. Next, this explains how the photoelectric effect works. So, when light shines on a metal surface, electrons can be emitted if the photon has enough energy to overcome the metal's mode function. So, the second one is Einstein described this using the equation K maximum equals to hf minus pi, where K maximum is the maximum kinetic energy of the emitted electron. So we move to the next slide, which is the application of photodiodes in optical communication. So next, I will discuss one modern application of the photoelectric effect, which is photodiodes in optical communication. The photoelectric effect is the fundamental principle behind the operation of photodiodes. A photodiode is a semiconductor device that converts light energy into electrical signals. It was when photons transfer their energy to electron generating and electric current. Photodiodes are commonly used as receiver in fiber optic communication systems where they convert transmitted light signals into electrical signals. So because of the ability to detect light accurately, this technology is widely used in modern communication and sensing systems. Electric effect remains highly relevant in many modern technologies. As listed on the slide, it is used in a fiber optic communication system, optical sensor for industrial and environmental monitoring, medical imaging devices, and scientific instruments that require precise light detection. So this application provides several benefits. They enable faster data transmission, improve light absorption to capture more photons, and generate stronger electrical signals. This slide highlights a recent advancement related to the photoelectric effect. So in 2023, researchers developed a heterojunction photodiode integrated with a silicon nitride waveguide for near infrared light detection. So according to the study, this device improved light absorption and photoelectric conversion efficiency. So this improvement demonstrates that Einstein's photoelectric effect continues to drive innovation in modern science and technology.
The electric effect was discovered by Albert Einstein in 1905. This discovery became a foundation of quantum chemistry and is used in many modern technologies including motion sensors and photodiodes in optical communication.